Welcome to CityEngine Essential Skills. In this video, we're going to introduce you to CGA, the rule-based language that CityEngine uses to generate 3D models. Imagine you've just started working in a city's GIS department. You've been given a set of 2D building footprints and are asked to build a 3D model from the 2D building information. In this video, we'll show you how to go from this 2D representation of the building footprints to a 3D model using CGA rules. You can download the data for this tutorial from arcgis.com. To get to this page, type in your favorite search engine, CityEngine Essential Skills arcgis.com. In the list of results, you'll see CityEngine Essential Skills Training project files. If you click on that, it will take you to the arcgis.com page where you can download the data. Now let's go to CityEngine and import the project files we just downloaded. Go to File, Import Zipped Projects into Workspace, and choose the CityEngine Essential Skills Training folder. Click Finish on the Import wizard to load the project into the Navigator window. Now open the Scenes folder and load either of the last two scenes you see here, starting with 04 Finish. To load the scene, I'm using the right-click Open With option, but an even quicker way is just to double-click the scene you want to load. If prompted to generate models, choose No. Once the scene is loaded, if you can't see any shapes, just make sure the Show Hide Shapes button is checked on. Now let's write a rule to apply to our building footprints. To create a new rule, in the Navigator window, right-click on the Rules folder and choose New CGA Rule File. Now we can give the rule a name. I'm going to call it GIS_building. When you're done, press Finish. Your new rule will open in the CGA editor. There are some standard comments on the top with the file name, the date created, and the author. And there's also a version number here that's inserted with the current version number. This is required for the rule, so be sure not to delete it. Let's begin by creating a start rule to trigger model generation. So just type in @startRule, and beneath this type a name for the start rule. I'm using the name of the incoming starting shape building footprint. We can designate this as a rule by adding 2 dashes and a greater than sign. Now let's add a single operation, extrude. The extrude operation will take the 2D footprint shape and move it through space to form a 3D volume. In this case, we're extruding 5 meters. Now we will save the rule and apply it to a shape. Hit the Save button or Ctrl S to save. In the viewport, select one of the footprint shapes. To apply a rule to this shape, just drag the rule file from the Navigator onto the shape. Once the rule is assigned to the shape, it will automatically generate. Now hit the Frame button to zoom in and take a closer look. You have now written a rule and applied it to a 2D shape to generate a 3D model. The general workflow for writing rules is to iteratively refine the rule, saving and regenerating as you go. Go back to the rule now and change the extrusion height. Hit Ctrl S to save and Ctrl G to generate, and do this a few times to get the hang of it. We saw how you can change the extrude height by changing the code, but CGA rules also take input through the inspector in CityEngine. So let's control height, this time using the inspector. To do this, we'll create an attribute. Attributes are generally defined at the top of the rule, but they can go anywhere in the rule. So let's add an attribute by typing attr and call the attribute height and give it a value of 5. Next, replace the number in the extrude operation with your new attribute height. Notice we have an error here. If I hover over it, it says there's no such function as height. CGA is case sensitive, so if I change this lowercase h to uppercase, the error disappears. Now reselect the shape and save and generate. The building now shows your height attribute in the inspector window. You can see there's a sliding value control here. The range of values in the slider are set automatically by CityEngine. To specify the range of the slider control, we'll use annotation placed directly above the attribute. Go back to the CGA editor, and above the attribute type @range, and in parentheses put 3, 30. Reselect the model if necessary, and save and generate. In the inspector window, look at the slider. It's now constrained to the new range. Now you may also set this value manually. Type any value into the height attribute. To return to the default rule value, open the connection editor next to the value and double-click Rule Value. Now our building needs a roof, so let's make another attribute in the inspector for roof type. Type ATTR roof type equals gable and put gable in quotation marks. Now look at the difference between the height and the roof type attributes. Height is a number, while gable has quotes around it. These quotes can hold strings of characters, numbers, symbols, and spaces, and are called strings. Now let's define a few types of roofs using the @range annotation, along with strings representing our choices. Above the attribute, type @range, and in parentheses, type gable, hip, flat. And put each of the roof types in quotation marks. Hit save and notice that the inspector reflects this change. But changing the roof type produces no change because we have to tell the rule how to use this attribute. So now go back to the rule and we'll use some new CGA operations to create the roof. First, we learn to break apart the model into its component parts using the comp operation. Type the following: comp and in parentheses F, then in curly brackets top, roof, and close the brackets. Just like the extrude operation, comp is followed by parentheses containing an input to the operation. In this case, the letter F means that we're asking for faces. The brackets contain a set of selectors followed by more operations. So we are using the word top selector to select the top face. Then after the colon, we're calling a new rule called roof. You'll see an error flag on the left of the comp rule. Hover over it and you'll see undefined rule roof. So now let's write a new rule called roof. Below the first rule, type roof, followed by the 2 dashes and the greater than sign. Now we'll use a new command to color the roof. Type color and in parentheses type 1, 0, 0 and close the parentheses. This operation takes 3 parameters, R, G and B, or red, blue and green, the 3 colors used in each pixel of your screen. The one indicates red is on full and the others are 0, giving us a red colored top face. Save and generate to see the results. We now have a red roof, but our walls are suddenly missing. So let's take a further look at the comp function. Hit the F1 key to pull up the help, click into the CGA reference and find the comp operation. This is the first place to look when learning CGA. At the top, we can see how the operation is written. The part inside the bracket is what we need to fix to get our walls back. You can see it follows a form which can be repeated using different selectors separated by the pipe character. We use top to select the top face. Now there are many selectors here with different results. To create our walls, we'll use the side selector. Close the help and begin typing after the word roof before closing the bracket. Add the pipe character type side, colon, and wall. As with the roof, we still need to define a wall rule. So type wall, and then let's give it a color. In this case, 0, 1, 0. Save and generate. You can see that the walls reappear and they're green. So now you know the comp function, one of the most frequently used operations in CGA. Now we'll go back to the roof rule to learn a very important logic structure called a conditional rule. You remember we defined a range of values for our attribute roof form, but we haven't used them yet. We need the roof rule to apply conditional logic based on the roof form. At the same time, we will learn a useful debugging technique. Now erase the code in the roof rule and replace it with this. Type case roof type, two equal signs, then type gable in quotation marks, colon, print roof. We have 3 roof types, so now copy and paste that line 2 times. Replace the word gable with the 2 other types of roofs that we want to use, hip and flat. And all case structures must have an else case to handle conditions not anticipated. So now let's type else, colon, print roof. You may have noticed that every condition leads to a new rule called print roof. Type the print roof rule as follows. Print roof, and then on the next line, type print, and in parentheses, type my roof is, and put my roof is in quotation marks, and then type plus roof type and close parentheses. What we've done is set up conditional logic to handle each case of the attribute roof type. The print roof rule is a simple way to test that conditional logic. The print operation prints whatever you want to the CGA console. So from the window menu, open the console and dock it beneath the inspector. Now save the rule and press Ctrl G to generate. Then try each of the roof type values in the inspector. You will see the print operation telling you which type of roof you picked. If you enter a roof type that's not in the range, then the else case handles that. Look back at the print command now, and notice how it combines a string and an attribute value. The quotes around a string you can use to identify the values that you're looking at. The plus sign is adding together the string and the attribute value. This is called concatenation. This results in a new string that you're printing to the console. These strings and values can be concatenated many times to create any complex string you'd like to see. Now let's replace the debugging code and create our roofs. For the first case, replace print roof with a new rule call. Type gable roof, and then start the gable roof rule as follows. Type gable roof, 2 dashes and a greater than sign. At this point, the single top face is entering the conditional rule roof. And the same shape, the top face shape, is being sent from roof to gable roof in the CGA code. Use the CGA help to find the operation roof gable. Press F1 to access the help quickly. Notice that there's 5 different ways to call roof gable. Let's use the third one, the one that has 3 parameters. Copy this line from the help file and paste it into your gable roof rule. You'll see a compiler error next to that line, and that's because we haven't defined the 3 parameters yet. Just replace them with the values of your choice. I'm using an angle of 30 and both roof overhangs are 0.3. These numbers can also be attribute driven, just like we set up in the beginning with the attribute height. Save the rule and set the inspector attribute to gable, and it will generate the roof. Next, we do the same steps to make the hip roof. Find the roof hip operation in the help documentation. Copy the version with 2 parameters. Now this time, just for demonstration purposes, we'll do it a little differently. In the case structure within the roof rule, replace the next print roof with the roof hip operation and replace the parameters with these values, 45 and 0.5. This time we're simply calling the commands inside the case structure rather than creating a new rule. Now save the rule and pick the hip roof type in the inspector window to see the result. Now let's work on the last roof type, the flat roof. Now the flat roof is the easiest since it's already flat. So let's look at another way that we can handle conditional logic in CGA rules. Let's rewrite the third case as follows. Replace print roof with flat roof and add a terminator. The terminator is simply a full stop. Since we already have a flat roof, we don't need to do any further processing. And the full stop says to stop processing and names the final shape flat roof. You can think of this as a rule call with no operations. Sometimes they are just used as placeholders for development at a later time. Now let's think of it that way and let's go back to write a better rule. First write the rule, flat roof, 2 dashes and the greater than sign, and then on another line, type extrude, and in parentheses, 0.5. Now let's save the rule and generate, and pick the flat roof type in the inspector window. Notice that it's the same flat shape that we had before. That's because we forgot to remove the terminator. Change that line in the case structure by removing the full stop at the end of flat roof. Save the rule and hit generate to see the results in the viewport. Now the flat roof rule is being called. Now some quick comments about what we've just done. Our rules are simple so far, but they can be expanded into fully detailed buildings because we can keep adding more refinements to each shape generated. Maybe you want to actually comment on these within the code. So let's leave a note to expand the flat roof rule later. So here I'll type #note, expand this rule later to create a parapet edge. Comments are a generally good coding habit. They help explain your code to anybody reading it, especially to yourself. Notice that we still have an undefined rule here, print roof. That's because I deleted it earlier in the tutorial. So let's go ahead and add it back in. So type print roof, 2 dashes and the greater than sign, and then on another line type print, and in parentheses, my roof is, and put my roof is in quotation marks, and then plus roof type and close the parentheses. At this point, we've created a CGA rule that transforms a 2D building footprint to a 3D building model. We've developed the rule using a single shape, but our goal is to model the whole city. Before we do that, let's zoom out and check the rule against some of the neighboring shapes. Select some of the shapes and drag and drop the GIS building rule onto the selected shapes. Notice that all of the buildings have the gable roof type. If you can't see the roof structure clearly, under the view settings, make sure that wireframes are turned on. All the buildings have the gable roof type because the default roof type is set to gable. We don't want to have to set each roof type by hand, so let's check the city's GIS data to see if there's a roof type attribute. Notice that there is an Object Attribute tab in the Inspector window. Open that and you'll see the attributes that belong to the GIS data. For our data, I don't see roof type here. So let's use a random function to address this. To generate random roof types, we'll use a stochastic function. Beneath the attribute roof type, type random roof type equals. And on the next line, use a percentage like 30%. Place a colon, and we want to type the roof type that will have 30% of the time we use this rule. So I'll type gable. On the next line, type 30% hip, and place each of these roof types in quotation marks. For the final 40%, type else. This is the same as the case logic structure. It must have an else. And the else case will be flat. Now to use this rule, copy and paste a random roof type and use this as a default for the roof type attribute. Now we have an attribute roof type, and this roof type equals the function random roof type. Random roof type will return 30% gable roof type, 30% hip, and the rest will be flat. Now save the rule and generate to see the results in the viewport. Now click on the Update Seed and Generate Models button. When you hit that, all of the models selected will try a new random value. Now that the GIS building rule is complete, let's generate the entire city. Zoom out so you can see the whole city. Select all of the building footprints and drag and drop the rule onto the building footprints. Now you can see we've generated 3D building models for the entire city and they all have random roof types. In the next video, we'll build on this rule to create a more detailed 3D model.